Hello, my name is David Jones, and I want to introduce to you my new invention. It's called a water reclamation canister, or basically a liquid waste can. It's a wastewater monitoring system. It monitors all instances of water that we waste in a shower, in a restaurant, or wherever. This is the book that I wrote about it. I used the title, The Aftermeal, because the word aftermeal is all encompassing. It encompasses uh, um, insects that crawl upon the earth's surface. It encompasses single-use items, the straws, knives and forks, the plastic single-use items, condiments, and the cups. In this book, I describe a little bit more about this product. This book was published in 2017. I've been writing and conceiving about this product for the last 20-something years. I've been working on it. This product is a combination of a waste management system, water reclamation, and water recycling systems all combined in one. This is the cover. I'm gonna just take it off. It represents chamber 1, where most of the ice is collected and potable water is collected. For example, every time you go to a restaurant, the waitress gives you that water with ice in it that you don't drink. After you don't drink it, this is the kind of a machine, a liquid waste receptacle that we need. We take our cup, empty it out, and stack the cup up. If the cup has ice in it, you pour it in Wally Well's mouth. Wally Well separates that ice from the machine, the cup, and it allows us to, if you are drinking milk, for example, you pour it in. Once you get it, and the ice that's in the milk would separate, and if you had a straw in your cup, you take your straw out and stack it separately. You'd empty your cup into Wally Well's mouth. The ice separates, comes into chamber 1, and you stack your cup. So what we've got is all the straws, knives and forks and condiments, single-use items stacked up through the top. And a little orange juice. I hate to throw this away, but that's how we do it. And this is just a cover. I'm going to take him off. Wally Well cover. It helps us, trains us on how to deal with gray water. So this is the system without the covers. This is what it looks like. And a little peep inside, you see the ice that we separated. It's the back of the unit. So the unit has input and output valve. That blue tube is connected to the sewer. The green line are input, and the other line is output lines, and they're connected up to our demo. This would represent the storage tank. It's empty right now. This would represent, say, a kitchen sink, wherever we collect water, a tub. What if this was a shower, for example? We would be collecting water. We put sensors in here. We've got laser sensors, optical sensors that'll tell us if the water's cloudy or not. If it's cloudy, we let it go into the drain. If it's clear, straight gray water, we'll recycle it to this tank. Here's a slight demo of how the shower would work in the future. I hope we've got enough water to make it work. Anyway, the water will accumulate here in the shower. See if we can get some of this water to come down. We haven't got enough water to make the shower work. Let's see. Okay, this is simulating the shower, how the shower would work. The water comes down. It actually trips the sensors, causing the machine to come on. As soon as it gets enough shower water in it, the machine comes on. Activated by water level sensors. We have water level sensors in this rain barrel. This is a rain barrel with water in it. We control water connected up to the machine. He'll cry all day long if we don't give him all the water he needs. Okay, back to this machine now. The water level sensors got us going crazy here. Okay, now back to the system. What we got going on here is it separates ice from drinks and it accepts potable water. To get this section of the machine to do what it does, we have to add more water to the chamber one. What's going to happen in chamber one is all of the ice that's been collected here is going to be filtered. It's going to be chlorinated. We're going to pump water into this section to clean this section out, where we put all of the bad liquids. If we got strawberry shakes or anything like that, we can dispose of any kind of ice water in this section by lifting and throwing it in there. So what we want to do is get this machine to start working from the ice. The ice will take about 2 minutes to melt. The machine runs a program. It first cleans itself out, then it starts melting the ice for about 1 minute. We can time the ice melting section and basically get it to however long we want it to run on cleaning out the ice. And then after the water is cleaned and purified, it'll be pumped up into a holding tank and then dispersed into a toilet or lawn application. Okay, let's put a little more, see if we can get the water level sensors to trip. Okay, machine comes on. It actually starts cleaning out this section. It sends water down there for 30 seconds and it'll clean this section out. Then it starts acting on the ice. For 1 minute, the machine is going to process this ice, melting it, cleaning it out, and melting the ice. Once the ice is all melted, in about a minute or two, it'll start processing the water and kicking out nothing but clean water to the holding tanks. We're going to watch it work here for a little. This is how it melts the ice. Ice is going down. It cuts off after about a minute of processing and it starts kicking that water out as processed water into the storage tank. And it sits there and waits until we get more water to process, chlorinate, filter, kick out into the storage tank. We can also set up filtering units that process the water once it starts cycling and cleaning itself out. As gray water can only be held around for a 28-hour period, it must be continually recycled, rechlorinated, This machine acts just as a swimming pool does on the water that it gets out. This is all water that we save from wastewater. We're using wastewater to generate a source of water for toilet and lawn applications with the system. This machine is totally programmable and can be interfaced from the web so that we can remotely monitor and control every device in the home that this machine is connected up to. This is the base, bare necessity for an intelligent home. Intelligent homes must be ones that can dictate and mandate what happens with water, gray water.